Good evening, everyone. Today we are going to take lectures on swimmer's problem. As one may know that one can swim in a pond or a lake or a river or in sea or even in ocean. But here we are going to take in this discussion of swimmer's problem or river. However, rivers are very wild in nature. Especially we talk about the rivers of Kosi belt in Bihar are very wild in nature, means lakhs of hectares of lands are useless. Once these rivers are organized, then it will provide a lot of lands to utilize judiciously. However, these kinds of things just we are discussing here to create the interest in the subject. So now just we are going to take a very ideal river in the discussion of swimmer's problem. Look at now. Heading is here, swimmer's problem. So here river is very ideal one. Look at here. We suppose that width of the river as it goes on from one side to the other, say east to west or north to south or maybe any direction. So here width is say d supposed to be constant. Suppose swimmers is here at one of the bank, or you may call it shore at A, wants to cross the river. It means water flowing. In general we call it flow speed of river, but in genuine is the flow speed of water. This is the U. U is the speed of the water flowing in this river. Now take it origin here 0 0, take it as a x-axis and here is y-axis. For the sake of simplicity, we take an angle theta from the vertical in anticlovescence, in which way the swimmer heads to swim. Look at here. V is the speed of the swimmer with respect to still water. Here sometimes one may get confused regarding still water. Sometimes we take it water is at rest. No, it is not so. Still water means there is no any vortex or tide in the river. Vortex, it means water is moving or rotating in one particular point. So no such things during the course of flow of water. Might have been there is no tide as well. So in this regard we call it still water, but water is still flowing with some speed. It means still water. Okay. Now there is also there are various techniques swimmer may apply to swim. One may swim in standing like that. It may be tilted, but we take here the swimmer is lying on the surface of the water. And try to swim like that. Try to swim like that. But in fact, swimmer may swim as he or she likes. But here we are going to take a very simple case by taking in mind that if swimmer is all the time lying on the surface like that, then acceleration due to gravity all the time is downward. But a question arises here, is swimmer may provide some acceleration or might be boat or ship may provide some acceleration? Answer is yes. We will take one problem that right now we are discussing here, very simple case is that swimmer or boat or ship swim with constant velocity, means there is no acceleration. Now what about acceleration due to gravity? Because we are taking the special case in which the swimmer swims or the boat goes or the ship goes on the surface of the water all the time, lying on the surface. So G is all the time vertically down. So no way it has acceleration in the horizontal direction, either in the positive x or in the positive y, negative x, negative y. That's a very simple case, because majority of problems may be asked on this simple situation is that swimmers is all the time lying on the surface of the water and maintaining its constant velocity. Mind you, I am not taking the constant speed. Constant velocity means speed is also constant and direction is also maintaining constant. That is why I am pointing out here. Look at here. So this is the direction of the swimmers. So swimmer all the time wants to maintain this direction theta. Once theta has been fixed, then fixed for forever during the swim, or if he wants to cross the river, then during the crossing time. That is very clear, keep in mind. So, but here is the flow speed, water speed. So, definitely water tries to drags he or she or boat or ship. But the swimmers, boat, ship maintaining his or her or it constant velocity. That is why. So, just we are going to use the concept of relative velocity as we had discussed earlier. If you are not well aware about that, then firstly go through those lectures and then try to see this lecture. Okay, look at now here, velocity of swimmers. Here we are taking swimmer. You may apply in case of bottle shape as well. With respect to ground frame or the shore or the bank of the river is equal to velocity of the swimmer with respect to water plus velocity of water with respect to shore or the ground frame, which is supposed to be stationary. Keep in mind, as we had discussed in the earlier classes, these relative concepts are applicable if the speeds are measured with respect to same frame of reference and magnitude of these speeds are very, very less than the speed of light.
One additional thing is that
Medium are also same. Otherwise, we will not arrive at desired result, as we had discussed. Go through the earlier video. Okay, so these are things here. So here just we want to write here Vsx. So here Vswx component, the Vwx component. So look at here. To find the component of a vector, as we had discussed, there are three methods: trigonometrical methods or geometrical methods or positive axis method through a smaller angle. But right now we are focusing on trigonometrical method. Okay, so look at here, VSWS is like, firstly we have to find the angle from the positive direction of x-axis in anti-clockwise sense. So angle here, look at, this is the 90 degree and plus theta. So here this is modulus of velocity V cos 90 degree plus theta, plus here water is flowing in the positive direction of x-axis, then this velocity vector makes an angle of 0 degree with the positive direction of x-axis. So we write here modulus of vector u and the cos 0 degree. Now it comes out to be minus v sin theta, because cos 90 degree plus theta is minus sin theta. Put minus outside and write like that, minus v sin theta, and here u cos 0 degree comes out to be 1, so this is u. Now in a similar fashion we are able to find Vsy. So look at here, only we have to replace cos by sin. Is the mod v sin 90 degree plus theta plus modulus of vector u and sin 0 degree. Sin 0 degree. So it comes out to be here v cos theta. And this sin 0 is 0. So multiplying any defined quantity with 0 comes out to be 0. So this is 0, comes out to be v cos theta. This component of velocity with respect to shore or bank of the river, that is with respect to ground, and ground is supposed to be stationary. Okay. Now, so look at here. One thing is very clear. If swimmer swims making angle theta 1 or theta 2, might have been angle from this way. If we take, look at here, we are taking this angle as a positive, so that angle must be negative. So in the majority of teachers and the majority of books, you may find that angle has been taken from the flow direction, but for some reason we have taken from positive direction of positive axis in anti-clockwise sense. So if in one particular problem angle is provided from flow, then we have to manage these angles in such a way that result will be applicable when angle has been taken from the positive direction of y-axis in anti-clockwise sense. So we will manage these things later on, but right now take like that. So here if the swimmer reaches here, this point, that point, it all depends on that. What is theta and what is the u, because u is all the time dragging it. So we will take this also into account later on, but right now, whether if the swimmer succeed to cross the river or might have been landed here, there, anywhere, one thing is very clear. What is these things? Guess it. Just I am giving you few seconds to guess it. Yes, time is over. Look at now. So the y coordinates will be same for
every one of the points.
y coordinate is okay. That's say this is the width of the river D. And this speeds Vsy, it means component of velocity. In fact, y component of velocity is v cos theta. So this is constant because swimmers has to maintain the constant velocity, then theta must be fixed.
With respect to still water,
As we have already assumed that it is velocity is constant, means speed is also constant. If a vector quantity is constant, means its magnitude and direction both are not varying as time goes on. That is why. So v is constant, theta is constant, it means cos theta is constant, it means Vsy is constant, speed is constant. And the y component is d all the time, whether no matters in which points the swimmer's boat seat lands there, here or anywhere on the opposite time. So we may apply dvt, means distance is equal to speed into time when speed is constant. Look at here, speed is constant. So we are in a comfortable position to apply this result. So dvt, distance d is equal to, look at here, v cos theta into t. This is the crossing time t. So this implies t is equal to d over v cos theta. d over v cos theta. This is the crossing time. Now we want to find the x component. We are dealing the situation as the coordinates because it will provide comfort to us to deal with that. Look at here, x component, that is we are going to use x motion here. So x is equal to x naught plus v naught xt plus half axt square. This quantity is component, just we are going to find it out. So do not think over it. X naught, look at here, swimmer starts from the position origin, that is 0, 0. So x naught is 0. V naught x, look at here, this is taken as v naught x, that is minus v sin theta plus u into t. Later on we will apply this one, but right now, right here t plus half. What about x? Swimmers did not apply any acceleration and the swimmers is all the times lying on the surface of the water. So g is all the times acting vertically down. So its component either in the positive x or in the positive y comes out to be 0 because making 90 degree. Mod g vector cos 90, mod g vector cos 90, cos 90 make it 0. So x is 0. However, later on we will take a problem in which swimmers may apply some acceleration. Then we have to take into account these acceleration either in the x or y or in the both directions. So that will be very interesting. Wait for that. But right now there is no acceleration. Okay. So x is 0. So this is the t square. Then it comes out to be minus v sin theta plus u into t. The t is already found here. So this is d over v cos theta. So this is the x. Now it is very clear that because it is coordinate, so it may be negative, 0 or positive. If it comes out to be negative, it means swimmer lands somewhere left of y-axis. Comes out to be 0, then directly opposite to the starting point, say at point B. Might have been some point here C, then x will be negative. However, if we are interested to find how much away from y-axis, then take it mod, because distance will never be negative. So here if x comes out to be positive, it means the swimmer lands somewhere on the right, say somewhere at D. Look at here. So this is the advantage to deal with the x and y coordinates. That is why. However, we may apply here y motion, y is equal to y naught plus v naught yt plus half a by t square. So result will be same. D is equal to v cos theta into t. But we had discussed earlier classes that if speed is constant, then we may apply dvt. Okay? Or you may get the same result by using the y motion as well. Okay. So these are the things here. X is equal to that case. Now you are interested that swimmer wants to cross the river just opposite to the starting point, say at point B. Where is the point B? Look at. Point B is on the y-axis. What is the unique character of y-axis points? X coordinate will be 0. That's the unique character of the y-axis. As well for the x-axis, y coordinate will be 0. So, just we are going to write here, swimmers wants to reach just opposite to the starting point, that is at B, then x coordinate will be 0. This implies, look at here, this is equal to 0. So D is not 0, V is also not 0, cos theta is also something here. So this multiplied or divided. So this quantity taken as a one quantity. So 0, it means sin theta is equal to, this implies sin theta is equal to, look at here, u over v. It means the swimmer heads at an angle theta whose sine is u by v. Then guess what is the path of the swimmer? Which path swimmers followed to reach the point B? This is the path. So look at, swimmer swims in that direction, But path is this, due to dragging of the flow. That is why. Swims at constant angle, it means has been dragged twice, and this is the way A to B. This is the way A to B. Keep in mind, very interesting. So, this is the very fine result, but just we are going to indulge in this result. Look at here. We all know from trigonometry is that sin theta never exceeds 1 and also never less than -1. It means sin theta belongs to closed interval -1 to 1. What does it mean? It means here u is less than v, otherwise it cannot be balanced, because left hand side is sin theta cannot be greater than 1, then definitely right hand side must be less than 1, otherwise it cannot be fulfilled. Now another interesting case is that mathematically sin theta is 1, okay, theta, one of the angle is 90 degree, however too many angles, 5 pi by 2, 9 pi by 2, 13 pi by and so on, too many angles, which provides you sin theta 1, because it is not a trigonometrical function, it is scalar trigonometrical functions, keep in mind. But we study generally trigonometrical functions. No, it is not a trigonometrical function, it is scalar trigonometrical functions, that is by too many angles, whose sine gives you 1. But in this particular physical situation, 90 degree. But let us see, is this 90 degree mathematical solution here is applicable in case of this physical situation? Just we are going to examine it. Look at carefully. So if u is equal to v, means sin theta is equal to 1. This provides at least one of the angle. Theta is equal to pi by 2 radian, means 90 degrees. Is this mathematical solution will give you physical comfort? Answer is no way at all. Look at how. If theta is 90 degree, it means swimmer or any boat or ship tries to move in this direction. So no way to reach the opposite bank. So this mathematical possibility is ruled out in this physical situation. Okay, so this is the case. And what about if u is greater than v? No way, because it is mathematically not fulfilled. So if mathematically not possible, no way to apply in physics. So u must be less than v in this physical situation. But one might argue that, sir, is it never possible to swim if swimmer speed is less than flow speed?
Answer is no.
Then how? Then how? We will take this situation later on, but right now we want to find minimum crossing time. So we have to think of time function. What is the time function we have got? Look at here. What the time function we have got? Look at here. Time function is this one. T is equal to d over v cos theta. So it is a function of d, width of the river, supposed to be constant, like ideal river. V, speed of the swimmer. Theta, the angle at which swimmer wants to swim. function of three variable. Look at here. Keeping d and v are constant. We want to vary theta. So again, you may ask, sir, we have told that velocity is constant. If you are varying the theta, it means velocity is not constant. Yes, okay.
Once we have not chosen theta,
Now we are trying to choose the theta. In this regard, we have taken theta is a variable and time is variable. Okay. So we may minimize the time dv and theta. But here we are taking d and v.
width of the river and speed are constant.
So once theta has been chosen, so chosen for forever. So in this regard, velocity is maintaining constant. Keep in mind all the time. So here theta is variable because we have to choose the theta. In this regard, we are taking theta is variable. Once chosen, then okay. So this is time is only a function of theta. Look at here. It means if we use maximum value of cos theta, then we will get the minimum time. That is the minimum time of crossing. Again, like that of sin theta, cos theta lies between -1 and 1, including -1 and 1. So maximum value of cos theta is 1. Put the maximum value, get the T minimum. The T minimum comes out to be d over v. D over v. Okay. Now we want to use this one to find the x coordinate, that is called drift. Horizontal shift. Okay. So the x coordinate now x equal to, as we had used earlier in this class, minus v sin theta plus u into t. T is comes out to be here T minimum d over v. Look at here how this d by v comes out here. Look at cos theta is equal to 1. If cos theta 1, then this implies sin theta 0 and vice versa too. So sin theta is 0. So this term, first term comes out to be 0. This comes out to be ud over v. ud over v. So this is the case, the drift and the minimum time. Look at right now here. T is equal to d over v cos theta. So this is the time function. Whatever the speed of swimmer with respect to water, either swimmer speed is less than flow speed or greater than flow speed, this time function remains same. Now the question arises, what will happen if swimmer speed is less than flow speed? So we will take this one later on, but right now just I am going to take a problem on this part of the swimmer's problem. Look at now here. U is the speed of flow of water and V is the speed of swimmer with respect to still water. V is the speed of swimmer with respect to still water. Now we have to show the path followed by the swimmer if the swimmer wants to swim in minimum possible time. As we have seen right now, swimmer all the time tries to swim
perpendicular to the flow.
and due to the flow speed drift like that, I am just showing just a bit larger. It means it is very small. So like that here. Like that. So this is D. This is we have calculated earlier. This comes out to be UD over V. And this is the path. You may join with a straight line. However, it is exactly, it is been dragged down and then try all the time. So you must try to swim perpendicular to the flow. That is why. So what is this one? So this is 90 degree. So this path length is comes out to be supposed to be a straight line here. The square root of using the Pythagoras theorem, it comes out to be d square over ud over v whole square, like that. This is the shown path and the distance covered. You may find quite easily. Now the second problem is that, look at the second problem. Here is the river.
Water flows with speed u.
Width is d, supposed to be constant throughout, as long this river exists. Now the question is that swimmer succeed to swim perpendicular to the flow. Say with the speed v, then find the angle made by the swimmer from flow direction. So this is the path. Look at here. This is the path by the swimmer, followed by swimmer. So as we had seen earlier in this class, swim at an angle theta whose sine comes out to be u over v. U over v. The question is that find the angle in which direction swimmers swim from flow direction. So we have to find this angle. Look at here. So this angle comes out to be, say this is alpha, then alpha comes out to be theta plus 90 degree. What is theta? Look at here. Sine inverse u over v plus 90 degree. Now, the last question of this class is here. Look at the problem number 3. Flow speed, say 4 meter per second. Swimmer crosses the river perpendicular to the flow. Means this is the path followed by the swimmer. And it is already given that swimmers headed to swim at an angle of 30 degree with the vertical in anti-clockwise sense. So this is 30 degree. Look at here. Then we have to find the swimmer's speed with respect to still water. So we have to find v. Now look at the swimmer swims At angle 30 degree means sin 30 degree must be equal to u over v. So solution is very easy. Sin 30 degree is equal to u over v, as we all know sin 30 degree comes out to be half, and this u is there 4 meter per second. So this is the v. Look at here, this implies, so this implies here, this implies v equal to 8 meter per second. Now on this part, just we have taken few simple questions to you to acknowledge what we had learned in the first part of this semi-inverse problem. Now in the next class, we will take second part of the semi-inverse problems, and then few simple problems, and then we will take some good problems on semi-inverse problem. So wait with curiosities for the next class, and then the next class for the few nice problem. Okay, thank you.